All right, so we're here at Linaro Connect. So what did you do here at Linaro Connect?
So I'm here representing Red Hat, and in particular Red Hat's ARM team, which I run. I'm Jon Masters, and I'm also a Fedora ARM contributor. So I have kind of two hats, a Red Hat and a Fedora hat. Red Hat is a member of Linaro these days, so we're working as part of the Linaro Enterprise Group to kind of work on the first generation of ARM servers. And as part of that, in the Linaro Enterprise Group, I'm helping to define kind of the items that we're working on there, and then also represent Linaro Enterprise Group in the core Linaro Technical Steering Committee. So this week has been a combination of various Linaro Connect events, lots of different people I've been able to catch up with and chat about different kinds of ARM topics, and then preparing future work items for LEG, working with the Technical Steering Committee for Linaro, just a huge different variety of topics, from meetings to engineering items to looking at code, the whole range of different things. It's been a very, very busy week, but it's been awesome.
What goes on at these meetings?
Well, the meetings that we're doing are effectively, we've set up an enterprise group, which is a collection of engineers from different companies. And what we're trying to do is solve core Linux on ARM engineering issues. So for example, 64-bit ARM servers are coming, and they will be based on EFI as a boot mechanism, which you may know from x86 systems. And they will use things like ACPI, which is a very sort of server-focused device enumeration technology that's popular on x86 systems today. And what we need to do is we need to work out, okay, what are the requirements for these servers that are being defined in terms of those that are building them and designing them, and then how do we make those work with Linux? So we have 22 engineers working in the Linaro Enterprise Group, and we need to figure out what are the priorities for them, what are the different areas we should be working in, and how do we constrain ourselves so that we don't try to bite off more than we can chew. So there's partly a planning exercise, and then there's also, I've been here with two Red Hat assignees, so Al Stone and Fu Wei, who are our first two assignees into Linaro, engineers that work for Red Hat but spend their time on Linaro projects. And these guys have been sitting with me talking through code issues. I was sitting with Al Stone looking at some ACPI code issues, and we've also been looking at testing with Fu Wei, who's working on the Lava test system in Linaro. And then, beside those meetings, there have also been the regular tracks. So we've been looking at just core ARM v8 topics, core Linux on ARM topics, Linux server topics, working with the Linaro kernel team to figure out how Fedora can better collaborate with Linaro to solve issues that we have together. So just a lot of different topics this week.
So how does Linaro and you and everybody figure out how to assign the different engineers doing all the different things and set the priorities and all that?
Well, that's where some of these lengthy sort of meetings come in, right? But what we're trying to do there is figure out what are the different priorities for the different members, what are the priorities to advance the cause of Linux on ARM, and then from that, what are the work items and how do we prioritize them? So clearly we know that we need to be able to boot a server to use it, okay? So we've got some things that I call minimal ship criteria, right? Turn a server on, provision it, okay? But that's kind of boring at a certain point, right? The reason people are looking at ARM servers is for the energy efficiency, for the system-on-chip features, the hyperscale features, the kind of, servers are like pixels on a display or disk blocks on a disk. You have so many of them in the future. You have, thousands in a rack, 10,000 in a single rack perhaps, millions in a data center in the future. And you won't be running around with crash carts, hooking up cables, fixing them. Instead, you'll install a whole data center of servers, and every 3 to 5 years, then you will take them all out, throw them away, and replace them. And as they fail over time, you have what's called fail in place. So basically, you just say that server went bad. It's like a bad disk block. So we've got to figure out not only how to provision these, which is a little different, but also how we handle some of the technology issues around that. So it's kind of minimal ship criteria. Then what are the interesting areas? Low-hanging fruit. So the obvious low-hanging fruit is around web servers, right? So a lot of people will initially use these servers for web serving, for Memcached, for the web tier, and then beyond that, we're kind of trying to prioritize, more advanced work topics for further down the road. It's last thing on a Friday afternoon, so I'm pretty tired right now, but I hope that's a good kind of summary of the different areas we're working on.
Very interesting. And how soon? Is basically when the hardware is ready, the software is going to be ready, everything falls in ready, and everything's going to work soon, or how soon?
Well, we already have ARM servers out there today, so both Calxeda and Marvell have produced some pretty good 32-bit ARM server hardware that's in production, right? Within Red Hat, we have 4 Calxeda-based servers right now that are building Fedora today. So there's a really good story already on ARM servers, and they're already in use. But I think the big wave is going to be when 64-bit technology lands, and there's some technology challenges there. But I think once the hardware is available, yeah, we'll have software ready to go.
Next year, by next year, it's the big wave is for sure happening.
There's a certainly forecast of 2014 being a big year for 64-bit ARM, and I'm looking forward to that very much.